complementary and supplementary. All right. What are they? Complementary angles are two angles that add up to 90 degrees. Two angles that have the sum of their measures total 90 degrees. Doesn't matter what the picture looks like, just if the measures add up to 90 degrees, they're complements. And we would say that like angle A is a complement of angle B. So in terminology, you would say that one of them is the complement of the other. What would be an example of complementary angle measures? How many degrees and how many degrees? Okay, 45 degrees and 45 degrees would be complements. Is that the only? 50 degrees and what would have to go with it? 50 degrees and 50 degrees? That's up to 100. 50 degrees and 40 degrees would add up to 90 degrees. They don't have to be the same measurement all the time. So 10 degrees and 80 degrees would be complements. So as long as they add up to 90 degrees, they're considered complements. And then the other term is supplementary angles. That's two angles that have the sum of their measures, or the total, to be 180 degrees. So you're still adding two angle measures, but they need to add up to 180 degrees. You would say that one angle is the supplement of the other angle. So what's the supplement of the 45 degrees that Hartman had to start with? It's a supplement of 45. What would it take to add up to 180? Okay, you're doing a different question. What's the supplement of 45 degrees? What's the supplement of 45 degrees? How would you figure it? Maybe instead of guessing numbers, there's a better way. Should we do an easier one? 10-degree angle. What's the supplement of a 10-degree angle? 5? 10 and 5 don't add up to 180. 7. Okay, so you're finding them by doing what, Austin? Okay, just subtracting. 180 minus the one I say is going to give you the supplement. And you, Dustin, you said 90 and 90. Okay, are 90 and 90 supplements? Do they add up to 180? 90 plus 90? 9 and 9 makes 18. And since your zero is 90 and 90 would be 180. So yes, our mental math here. Okay. So why don't you grab a marker board, I guess, so a whiteboard on your iPads. A lot of you are using EduCreations, but there are other whiteboards. Okay, let's see if you can do your subtracting correctly. I would like you to come up with the complement of 32 degrees. It's the complement of 32 degrees. So look to see, complements have to add up to 90. 32 degrees. That would be its complement. And let's put the degree symbol on. Show me. Question? What's that say?
20 degrees plus 12.
Okay, that's not what a complement is.
Oh.
What's a complement? How many degrees would it take to add up to 90? And what Austin Waller said to find it is subtract. So what would we need to subtract to find the complement? Okay, 90 minus 32, so when you borrow,
58.
okay, 58 degrees?
Yeah.
So 58 degrees and 32 degrees adds up to 90. So the complement of the 32 degree angle is a 58 degree angle. Okay, let's stick with that 32 degree angle. What is its supplement? 32 degree angle, what would the supplement be? Adding? Should be adding. What does it take to add up to 180? Now, if you want to think of it in an algebra equation, I could do this kind of thing. 32 plus what equals 180? And to solve it, you'd be subtracting 32 from 180.
I have it.
So 180 minus 32,
148.
148. It would be a 148 degree angle to do the supplement. Okay, let's keep going. I'm not convinced you can do it right yet. Okay, what angle should we use? Let's go with 64 degrees. What is its complement? What is its supplement? What is the complement of 64 degrees? And then what is the supplement of 64 degrees? That second number. That's the complement, and the supplement also. Six.
Oh, 60.
Line it back up. Right, you don't have your pen with you? You're wrong.
Yeah.
Okay. Okay. All right, we're getting better on that one. First one should have been 26 degrees, and then the supplement was 116 degrees. And you're just subtracting to find what the other one is. Just gotta do our subtraction correct. All right, adjacent angles. We'll probably come back to the iPads first. Adjacent angles are two angles that share a common vertex and side, but have no common interior points. They share a common vertex and side, so they're going to be hooked together in a picture. Austin, get your notes off down back there. But they have no common interior points. So they're side by side, they're not one overlapping the other. What would they look like? It doesn't matter what their degrees are, They could be big, they could be small, but they just have to be positioned correctly. Here's one angle. I'll switch colors and I'm gonna hook another angle onto that. It's gonna have this same ray and vertex, and then yeah, I could go down like this. So the red one and the green one are adjacent. They share a common vertex and they share a common side. This ray right here is a side of both angles. So that's called adjacent. Angle 1 and angle 2 are adjacent. What else could they look like? Here's one angle, and another angle. Angle 1 and 2 are adjacent. Angle 1 and angle 2 are adjacent. But what's not adjacent?
Like if one would be
Want to draw a picture?
sure.
Okay, come up here, draw a picture. He's going to try and draw something that's not adjacent. Okay, so if we maybe added another one out here.
Yeah.
Okay, did he mark two angles that are not adjacent? Correct, he did. This is, what we're doing is not adjacent right now, just so that you can compare. Okay. They are sharing the same vertex, but the two rays that make angle 1 are completely different from the two rays that make angle 2. All right, here's another picture. I'll just make two overlapping. Angle 1 and angle 2, are those adjacent?
Yes.
Do they share a vertex?
Yes.
Yes. Do they have a ray that is the same?
Yes. No. Wait.
These two rays are angle 1. These two rays are angle 2.
Yeah.
No. Sometimes we think yes because they're on the same line, but that doesn't make them adjacent. All right. I'm gonna, well, maybe I shouldn't do that because we're doing angles that are not adjacent. 3 lines in the picture, this angle and this angle,
Nope.
those are not adjacent. All right, so got the difference between what is adjacent and what is not adjacent. All right, I'm going to draw you some pictures on the board. Adjacent means hooked together. So notice how they're side by side, hooked together, so they are adjacent. They're hooked together, they're hooked together, they're not hooked together, they're hooked together, they're not hooked together. Perfect scores? Anybody get all of them right? All right, we did get. Any clarifying questions? Okay, let's try some angles here. Okay, name the angles described. I'm going to ask you to name something and then you name from the picture. Now when you name, what are you doing? Are you saying acute? No, that's a classification. In the name, you've got the angle symbol, and then you're probably going to have to give me 3 letters, aren't you? 3 letters. And which one's the middle one? N in this problem because that's going to be the vertex of every angle. All right, on your screen, I want you to name 2 congruent angles. 2 congruent angles. Find 2 that are the same, that's what congruent means. Their degrees are the same. The picture, they don't look the same, but the markings are there. Brandon?
CNA.
Angle CNA.
A. And CNE.
CNE, are there markings to indicate that those are the same?
Isn't that 90-degree angle in there?
Well, a 90 degree is the BN and ND, that part's 90, but that doesn't mean that this one right here is 90. It might be 89 and 91, it kind of looks like it, but notice you don't have a square corner with the CN and the NA.
Okay.
So, nope, I'm not gonna take that as congruent, because I can't tell from the picture that they are. But there are some angles marked in that picture that have the same curve to indicate they're congruent. Colton?
Angle B and C and D and E.
So notice he named the two that have the curve in them. So B and C has the curve inside it, and then D and E has the same curve inside it. I know my picture, that looks a lot wider than that one, but I probably don't have everything accurate there. Okay, in that picture, name a right angle. What angle is it saying is a right angle? Awesome. Say louder.
B and D.
E and D. Or completely reverse those letters and you'd have it. Okay, can you name for me an obtuse angle? Obtuse. Dylan? A-N-E. How many degrees is A-N-E? It looks kind of flat to me. Okay, A to N to E, that's gonna be 180. That's a little bit too big for obtuse. That would be classified as straight angle. So he can't go quite that far. Let's say he goes A-N, then where could he turn to make it just an obtuse? A-N-D would be an obtuse angle.
BNE.
B-N, B-N-E, she said, from B to N to E, yes. And then I'm not really sure if I could use C-N-A or C-N-E because I don't really, it's not real clear whether that's obtuse or not. All right, how about, can you come up with any supplementary angles? Two angles that you know would add up to 180 degrees. How many degrees is a straight angle?
Well, that's 180.
180. So can you get two angles that are hooked together in that picture, that when you put that angle and the next one together, that you get that whole straight angle? Try it, Austin.
DNA
Angle D-N-A and angle A-N-E. Okay, D-N-A, so he's naming this angle. And then, oh, A-N-E is a straight angle all by itself. So what can we put with D-N-A? Yeah, let's not go that.
BNE. That work?
Okay, you see the one that I've highlighted in red?
Yeah.
DNA. Okay, so what one could I put with that to get around to the straight angle?
BNE.
This is the little angle I would need to name to go with the red highlighted one. So it needs to be angle
D and C.
DN, not C.
E.
DNC would be this one. DNE is that one. Okay. DNE.
How can't you see?
All right, let's not get on each other. We're learning here. Okay, and on this picture, can you come up with two complementary angles? Two that you know have to be a total of 90 degrees. Two that you know would total 90. Austin,
B and C.
D and C?
B and C.
I should make some different letters up there so it doesn't sound like the same thing.
And C and D.
C and D. Okay, let's see how he did. B and C. B and C. So he named this angle over here. And then C and D right beside it. So that total, I did have marked was 90. Correct. All right, so picking some angles from the picture. All right, let's go back to some calculating. Okay, still got your marker boards. Find the value of the variable. If you'd rather have it in your notes, that's fine. But I think you're doing pretty good. All right, answer should be
32.
32 degrees. How do we know? Well, the total was 90 here with this marking. So 90 minus 58 should have come out to be 32 when you borrowed correctly. So the two angles in that picture are called complementary, okay? Now yesterday we were doing a bunch of problems where if this one was 58, then X was also 58. What were we doing yesterday?
Angle bisectors.
Angle bisectors, okay? This was not an angle bisector because it didn't say that they were the same. All right, next one, find the value of the variable. Add together to be 90. So they have to add together. So 3x minus 4 plus x minus 2 has to equal 90 degrees. Let's see, I have to solve it. 1x should have been 4x, and negative 4 minus 2 more was minus 6. Then you added 6, so 4x was equal to 96. Take 96 and divide by 4.
You get 14.
You
or
get
24.
24.
Yeah.
Correct. So I found the value of the variable. Now notice the directions that say, then find the measure of each angle. So let's go back and see, what were these angles? Well, what's 3 times 24, and then subtract 4. Help me out here. 3 times 24, and add 4, or subtract 4.
72.
68.
Minus 4, 68. Okay, so this angle was 68 degrees. This one is supposed to be 24 minus 2,
It's 22.
22. And weren't those two supposed to add up to make 90? Notice they do. So the answers were x is 24, this angle's 68, this angle's 22. Be sure you read the problems to see if you need to give more than just what x is. Okay, we kind of struggled on that one a little bit. But in the picture, they had to add together to make the 90 total. How about this one? What would x have to be? We talked about straight angles again. So if I go from one side all the way around to the other side, that has to total 180 degrees to make that straight angle. So I'm looking at supplements. This is kind of the picture. Dallas, what are you getting? Correct. 33 degrees?
Yes.
Yep. So you're just doing 180 minus 147, and that should come out to be 33. All right, next one. 5x plus 5 and 2x are the two angles. The picture looks the same as that last.
There you go.
Okay, and your equation was the 5x plus 5 plus 2x Had to be 180 degrees total?
Mhm.
7x plus 5 equals 180. Subtract 5. 7x equals 175. Divide by 7.
25.
X was 25.
Mm-hmm.
And it said find the measure of each angle. So 25, we can think in terms of quarters. 5 quarters plus a nickel.
130.
$1.30. So 130 degrees. 2 times 25, 2 quarters would be 50 cents. So 50 degrees. Same numbers that were up there. All right, question on that one. How many got it right? Did everybody? No? Okay, questions, setting it up. Mitch, did you know how to set up the equation? No? Jamie, what'd you get stuck on? Okay, did you have the equation right?
I know if I could keep in her original equation, she had 5x minus 5.
So that threw her off a bit. Okay. All right. Let's finish up with what the theorems are. There are a couple theorems that relate to complements and supplements. So finish this up and then we should have probably 15 to 20 minutes for homework. Okay, a theorem for your notes. We're going to have a lot of theorems in our course. A theorem is a true statement that follows from other true statements. If you recall from last chapter, we had a postulate. Postulate was a statement that was accepted as true without being proven or justified. Now, a theorem can be proven. So you might say that it's supported a lot more. A theorem is a true statement that follows from other true statements. It can be proven. A difference between regular geometry and basic geometry is the number of proofs that we do. In regular geometry, we do a lot more proofs than what we will do in here. But what is a proof? A proof is like a convincing argument. Like you would explain why this math theorem is correct. So we'll probably use more of them rather than prove as many of them. Theorems can be proven. So there are a couple theorems that deal with complements and supplements. The first one, theorem 2.1, which just means second chapter, first theorem. The title of it is Congruent Complements Theorem. Sometimes the title gives you an idea of what the theorem's about. So this one is something about congruent angles and complementary angles. As you're writing the words, it says if two angles are complementary to the same angle, then they are congruent. I've got some angles to fix up an example for you. If two angles are complementary to the same angle, then they are congruent. Set up an example so that hopefully you understand what this is saying. We'll say this is angle A, this is angle B, and this is angle C. Okay, I need to set up two angles complementary to the same angle. So let's say angle A is complementary to angle B, and angle C is complementary to the same angle B. Then what's the theorem say is going to happen? Then they are congruent. Which they do they mean? Well, A and C are complementary to the same angle, so they're saying A and C will come out to be the same degree measure. Okay, let's try it with some numbers. Let's see if A and C end up the same. A looks like it's a 30-degree angle. So if angle A is complementary to angle B, how many degrees is angle B?
30.
60.
Oh, yes.
Complementary, they have to add to 90. And if angle C is complementary to angle B, now we know B's 60, what's angle C? 30. So did we show that angle A and angle C end up the same.
Mhm.
So out of this, we end up with angle A congruent to angle C, because they are complements to the same angle. So if you know the theorem and I tell you some information, I really can give you one angle and you can figure out what the others are. All right, same thing works with supplements. So theorem 2.2 is congruent supplements theorem. It's going to sound almost the same as the one you just wrote down, but supplements instead of complements, which we should be learning. That supplements add up to 180, not 90. So we'll set up an example on this one. Austin, how late did you have to work? So 11's not the closing shift.
No, this is like 12:45.
Did I see they're hiring for closing shift?
Yeah.
Is that what it's saying? Maybe I'll get some college students that might do that.
It sucks.
Yeah, it would be kind of late, especially if you have to go to school. Okay, so if two angles are supplementary to the same angle. Now, looking at my picture, I really couldn't say angle P is a supplement to angle S, because if one's acute, the supplement has to be a lot bigger. So that's why I went with the angle T over there. Okay, so how about this time, instead of starting with angle P, I'm gonna give you angle T. Angle T is 130 degrees. Okay, so if angle P is a supplement to angle T, how big's angle P?
33.
50 and 130 make 180?
Yes.
Okay. And then if angle S is supplementary to the same angle T, so S is a supplement to angle T, that's 50 degrees also.
Yes.
So just like the last one, didn't we end up with angle P congruent to angle S? Alright, so on those problems, you need to maybe set yourself at least a list, angle P, S, T, and fill in what degrees they are. Maybe you want to draw a picture. This would be, I think I have two examples here. This is something like in your homework, they don't always have a picture. It says angle 1 and angle 2 are both complementary to angle 3. If angle 1 is 75, find the measure of angle 2. Now if you want to draw pictures, you can. Maybe at least list measure of angle 1, measure of angle 2, measure of angle 3. Okay, which one do we know first?
Angle 1 is 75.
Angle 175. Okay, it says 1 and 2 are both complementary to angle 3. So what's 180 degrees? What's that mean?
90.
Add up to 90. So which ones have to add up to 90?
1 and 2.
1 and 2 are both complementary to angle 3. Does it say 1 and 2 are complementary? No. 1 and 3 are complementary, and then 2 and 3 are complementary. So 1 and 3 have to add up to 90. So what's angle 3? 15. And then 2 and 3 have to add up to 108, or excuse me, 90. So 2 is 75 also. So what's the measure of angle 2? 75. Now if you use the theorem, it said these two angles that are both complementary to the same angle, they will end up congruent to each other. So notice 1 and 2 ended up both being 75. All right, and one more example. Angles 1, 2, and 3. One and 2 are both supplementary to angle 3. Angle 3 is 75 degrees. So angle 1 would have to be
15.
supplementary
No,
now.
75.
Supplementary.
Oh, God. Thinking 90,
No. Supplementary means
180.
they total 180. So angle 1 and angle 3 have to total 180.
115.
105.
Or 105.
And then 2 is also supplementary to angle 3. Angle
It's
2,
also
300.
75. Or
So it's 105 also. So find measure of angle 2, 105 degrees. All right, so you're gonna have to look at your notes, it looks like, to keep your complementary and supplementary. How do I remember which is which? What I've had students tell me is complementary. This is just the evens, that's what that capital E would indicate.